Okay, so last section is 1.6, and it's basically on how you can take two functions you have, combine them together, and make a new one. We're going to look at some simple ways we can combine them, and then we're going to look at another way we can combine them, which is called composition. The big focus of this section is domain and range. Right? So you may know what the domain and range were of your functions originally, but when you combine them together to make a new one, you're changing the domain and range. We have to figure out how does it change. Now the two big things we got to remember with domain and range, with domain, you never want to do what? Two things. You can't do these two things in math. Yeah?
Divide by 0.
You never want to divide by 0. So if you end up with a variable in the bottom of a fraction, we got to watch out for that. And you never want to do, we actually kind of just looked at it with the discriminant.
Square root of negative.
Yep, never want to take the square root of a negative. So if that's a possibility, we have to avoid that as well. So this is what I just said to you. We're going to take two functions we already have, and we're going to create a new function by combining them together. That's just what we're going to do. Okay, so here's our two functions, f of x and g of x. F of x is the function x squared, g of x is the function square root of x. Now, the first new function that I create is going to be f of x plus g of x. Now, first of all, are those two functions like terms? What do you think? Oh, Caleb? Are those two functions like terms? No. If they were like terms, f of x could be x squared and g of x could be 3x squared. Or 5x squared and 9x squared. Right? These are x squared and a square root. They're two totally different functions. So when we combine them together to create a new one by adding, there's nothing you can really do other than just write x squared plus the square root of x plus 1. Okay. If it was something like x squared plus 2x squared, then yes, I would combine those and write this, 3x squared. But I can't do that here. Okay. How about for f of x divided by g of x? How do you think I would write that one? Yep.
X squared divided by the square root of x plus 1.
Yeah, so we start with x squared divided by the square root of x plus 1. And now, what did we do here that you're not supposed to do with square roots? We're not supposed to leave them where? Yep. We're not supposed to leave them on the bottom. So when you have a square root on the bottom, what do you have to multiply by to fix it? Yeah.
2.
How about in general? Because like in this one, it'll be something specific, but like in this problem, it would be something different than that problem. Multiply top and bottom by
the denominator.
By the denominator, yeah, whatever it is. So square root of 3, or in this case, square root of x plus 1. And the reason we do that is because it cancels out the square root in the bottom. All you're left with in the bottom now is x plus 1. And the top, you can't really do much with it. X squared times the square root of x plus 1. So that one had a little bit of extra work because of the square root in the bottom. But any questions on how we created this new function? So first time we added them, second time we divided them. They'll always give you, in a problem like this, they'll tell you what the two functions are they want you to combine. There's more examples in your book on page 58. So now, how do we figure out the domain of these new functions? Okay. Well, here's kind of the big idea. if these numbers represent the domain of f of x, and these numbers represent the domain of g of x, where do you think the domain of the new function that we created is going to be in that picture? Yeah.
Where the overlap.
Yeah, it's the overlap. So it's all numbers that belong to both of the original domains. Okay. All numbers that belong to both of the original domains. Okay. Or the way I wrote it here, the domain is all x's such that x belongs to the domain of both original functions. Now, one thing you have to remember is that if you created a new function using division, you could have just created a problem where you divide by 0. And do we want to divide by 0? No. So, if I look at the original problems I had here, in f of x, is that a fraction?
No.
No. Is g of x a fraction?
No.
No. But I created a new function, doing what they told me to do, and now I have a fraction. And if x was -1, that would be a problem. Okay? Maybe it wouldn't have been a problem in the original ones. In fact, it's not. -1 is fine in both of the originals. But it's not fine in the final answer, because that would cause you to divide by 0. So just make sure when you write the domain, if you get a division problem, which sometimes they'll ask you to do, sometimes you won't, depends on the problem. But if you do, make sure the denominator cannot equal 0. Okay. The other thing, I already asked you guys this earlier, make sure you are not taking the square root of a negative. Those are the two things you've got to avoid. Set both of those up a bunch of times. All right, so what we're going to look at now is they're going to give us two functions. They're going to ask us to do something with them, and then we're going to try to find the domain. We're not going to worry about range yet. Okay, you got to get domain before we can get range. Okay, so here's the two functions they want to use: f of x and g of x. In either one of those functions, do I ever have to worry about dividing by 0?
No.
No, they're not fractions. Do I ever have to worry about taking the square root of a negative? Elias?
Yeah.
Yeah. If I plug in -10 for x in the top one, I'm going to get the square root of -7. That's no good. So -10, I can't use that. I want to write down what I can use. So what numbers would you have to pick for x in f of x? So you never take the square root of a negative. Zach?
C greater than 3. Or -3.
Close, good catch with the negative, that's important. Something with -3. But yeah.
X is greater than or equal to -3.
Greater than or equal. There is no problem at all with the square root of 0. Okay? Square root of 0 is fine. But you can't do the square root of a negative. So, every number greater than or equal to -3. This is how you write it. Put a bracket on -3. Bracket means including, comma, and then put an infinity and a parenthesis. This is the lowest value you can go, including it. This is the highest value you can go. And you can't include it because you can never reach infinity. Okay. How about my domain for g of x? What values would I have to pick there? Yep.
You can't go lower than 2.
Okay, can't go lower than 2, so tell me what I can do.
2 or greater.
2 or greater. You can pick any number greater than or equal to 2. So, we've got the domain of both of the original functions. Now we're going to combine the functions using addition. And see what the domain would be. So f of x plus g of x. Okay. Eric, are these square roots like terms?
Yeah.
Well, to have like terms, you have to have something like square root of x plus square root of x, and that would be 2 square roots of x. So like terms with square roots mean these things are the same.
Okay, so no.
No. So those are not like terms. So when you add them together, that's pretty much all you write. You can't really do anything with it after that. All right. So Jacob, what would I get when I write this down?
The square root of x plus 3
Yep.
plus the square root of x minus 2.
Yep. Now, if f of x was the square root of x plus 3 and g of x was the square root of x plus 3, and they were the same, then I could say, well, the square root of x plus 3 plus another square root of x plus 3 is 2 square roots of x plus 3. Okay? But they're different. They're different. Okay. Now, the domain. So think of that Venn diagram that I drew. The domain is the overlap. It's all the values you can think of that would work here and here. Has to work in both. Zach?
Greater than or equal to 2.
Yep. Greater than or equal to 2. And if you think, well, why not 0? 0 works here. 0 plus 3, that's a positive number. You can take the square root of 3. Yeah, 0 works here, but 0 doesn't work over on the right. So it's got to be numbers that work in both. Okay, so try to think of like that overlap. Any question on that one? Okay, let's do this one. So f of x divided by g of x. Okay, so Nakara, what? How would I write this one?
The square root of x plus 3
Yep.
divided by the square root of x minus 2.
Divided by the square root of x minus 2. Yep. Now, technically, we shouldn't leave the square root in the bottom. I'm not really worried about that for this one. If you want to fix it, we could, but we can leave it for this one. It's fine. What I want to write down is the domain. So you're going to be careful. The domain, again, it's all values that work in both of the original functions. Anyone think they can tell me what the domain is here? Jared?
Everything greater than 2.
Why greater than 2?
Because 2 minus 2 would get you 0.
And we can't have 0 in the bottom. Okay? So, small change. This one is greater than or equal to 2. This one is greater than 2. So, the reason it's greater than 2 is not because you're taking the square root of 0. Square root of 0 is fine. The problem is the square root of 0 is 0, and you can't divide by 0. That's the problem. You can't have 0 in the denominator. So, any question about the small change between the domain from A and B? It's small, but it's important. If you mix it up, it's totally wrong. Including, not including a number. It's a big difference. Okay. Yeah? So, we already know from the problem up above that the numbers that work in both of these functions are from 2 to infinity. So we already know that from part A. Now in part B, I say to myself, okay, if I try to use this here, would it still work? Now I remember from the notes, division, I got to be careful that I never divide by 0. So check the numbers in the domain and say, okay, let's try 2. Well, 2 minus 2 is 0, and the square root of 0 is 0, and then you divide by 0. So the domain, you can try the same one you had, but then check to see if anything in that domain would cause you to divide by 0. And if it does, just rule it out. Okay, any other questions on that? All right. Let's Okay, let's try this. So let's graph this on the calculator and find the domain and range. Let's type it in. So we've got f of x divided by g of x. F of x divided by g of x. Okay, I don't know if we've used absolute value. We might have done that in here, but I'll show you where it is anyway. We might have used it a few times. Math, number, option 1. Okay, absolute value of x divided by x. Let's hit graph. Okay, so there's the graph. So let's think about the domain. Are you taking the square root of a negative number in that formula?
No.
Never, no. There's no square root in the whole problem. Could you ever divide by 0?
Yes.
Yeah, this is a fraction with a variable on the bottom. What value would cause you to divide by 0?
0.
0, yep. So the domain here, this is how you write it. You can pick any number going as low as you want, up to 0, but you can't include it. Or you can pick any number from 0, not including it, as high as you want. So you can go as low as you want, up to 0, don't include 0, or, that's what that symbol means, it's a U, or 0 to infinity. So that's your domain. Now, range we'll do quickly, but we're going to spend more time on range later. Range is, look at your graph and tell me all the y values that your graph hits. Can somebody tell me all the y values that that graph hits? Yep.
1, -1.
That's it. That's kind of weird. We normally can't name every single number in a range, because usually they go to like infinity. But this one only hits 2 values, 1 and -1. Okay? So think about it. Plug in a number for x into this formula in your head and see what you get. Like plug in 5. Absolute value of 5, 5. 5 divided by 5, 1. 7. Absolute value of 7, 7. 7 divided by 7, 1. So you get 1 a lot. You get -1 if you plug in a negative number. Try like -8. Absolute value of -8, 8. Divided by -8, -1. So no matter what you plug in for x, you're always going to get 1 or -1 is the answer for y. Okay? So domain is what you plug in. Range is the answer you get for y. Okay? So, another way we can take two functions and combine them together is composition. So, it's like adding or subtracting, but it's a different way to combine them. And the big idea with composition is you are plugging in one function into another. Okay? I'm going to show you how it works. So, let's use these two functions. G of x is the square root of x, and f of x is x squared plus 3. That's what the notation looks like for composition. G of f of x, and that's how you pronounce it. So if I wrote down G of 4, what does that mean to do? Like, how do you figure out G of 4? What do you do with the 4, Zach?
F of x is equal to 4.
Can you say it again?
F of x would equal 4.
So G.
So that would equal 4. X.
Yes, x would equal 4 in function G. You take 4 and you plug it into the formula. So, look at the formula. Square root of x, square root of 4, 2. That's how you find G of 4. If I said G of 9, the answer would be 3. So if I'd said G of f of x, you're going to take f of x and plug it into g. Whatever you have written there, plug it into what's on the outside. Okay, so how's it going to look? Take what you have written there, it's what I just circled, and you're going to plug it in right there. Just like I plugged in 4, just like I plugged in 9. Now I'm going to plug in that formula. That's how you do it. So let's do it out. G of f of x. G of, let's just look up what f of x is first. F of x is x squared plus 3. Now, take what's in parentheses and plug all of that in for the variable in function g. So function g is the square root of x. So don't write x, plug in for the x. Plug in that. X squared plus 3. And that's the answer. We're going to do a couple more, but any questions on how I did that one? You just take what's on the inside and plug it into what's on the outside. If it's a number, fine. If it's letters and numbers, fine. Whatever it is, just plug it in. Now let's do it the other way. Instead of g of f, we're going to do f of g. You might think, well, what's the difference? It's the opposite. You're going to take function g and plug it into f. Okay, so let's look up what function g is first. What is function g? It's equal to
Square root of x.
It's the square root of x. So g of x is the square root of x. So now what that says is in formula f, replace all your variables with that. Okay, so let's do it. Look at formula f. X squared plus 3. Yeah?
1 to x plus 3.
Yep. So it's something squared plus 3. It wasn't x. We're filling in for the x. We're filling in the square root of x. Now, this one actually simplifies a little, as Zach just said. Square and square root cancel. And you get x plus 3. Now, in the next step, we're going to write the domain. You can't forget that you canceled out a square root. Yes, if I block everything else out, all you see is x plus 3. And you might think, oh, you can add 3 to any number. Yes, you can. But you didn't have an x originally. You had a square root in there. And you have to remember that. Okay, so I'll show you how we do that. Another notation you might see in the book, I don't use this as much, but if you see a letter, a small circle, and then another letter, that means this. I usually do it this way. But it means the same thing.
Almost like a degree.
Yeah, it's almost like a degree symbol. It's just a little circle between like 2 letters. So if you saw this, it would mean this. A of b of x. You'd be plugging the b of x function into the a function. All right, so how do we find the domain? So when you're dealing with composition, we have what's called an inside and an outside function. This is the inside. This is the outside. Inside one is the one that's in parentheses. Okay, so b of x is inside, a is on the outside. First thing we have to do is look at the inside function and see if there's any values there that should not be part of the domain. If there are, figure that part out. Look for square roots of negatives. Look for dividing by 0. So look at the inside function and start with getting rid of any values that shouldn't be in the domain from that. Now the second part is to look at your final answer. Like the one Zach gave you, the x plus 3. Look at the final answer and see is there any other values that we need to rule out from the domain. When we compose the function, did we make a fraction? Can all of a sudden we divide by 0? And that wasn't a problem before, but it is now. That's the kind of stuff you gotta look for. Okay, so we'll practice a couple of those. Okay, I'll also do one with you guys that's just a number. We'll practice just doing composition with a number. That's actually simpler than letters. So in example 3, my two functions I have are f of x equals x plus 1 and g of x equals the square root of x. And they want me to do a calculation. Find f of g of 9. So you always start inside and work your way out. So Brandon, what's the function there that's on the inside?
Would be the square root of x. That's what you plug
Yeah,
in.
function g.
Yeah.
So function g is on the inside, and what do they want me to plug into function g?
Square root of x.
Well, square root of x is the formula, but they want me to plug something in for x.
The 9.
The 9. They want me to do this first. Plug 9 into function g. Don't worry about function f, we're not there. So if you plug 9 into function g, you get this. What's the square root of 9? 3. So now what they want me to do is plug 3 into function f. Okay? That's basically what we did with letters before. With numbers, it's even simpler. So what do you get if you plug 3 into function f for a final answer? Yep. 4. Yeah, you get 4. You're not really going to have a ton of those, but that's composition with just a number. Now, let's do it again with letters. F of g of x. Chris, what's my inside function there? G of x. Take g of x, plug it into f. So, take g of x and plug it into f. So when you do that, you're going to get the square root of x plus 1. How about the other way? Can somebody else tell me when you plug f of x into the variable in g, what do you get? Yeah.
The square root of x plus 1.
Same thing I just got?
Oh. No, you have all of it underneath the square root.
All of it under the square root. Small change, but if you tie that in with what we learned yesterday, this is a vertical shift, the top one. This is a horizontal shift. So they're totally different. So you can kind of connect composition with transformations. And that's basically what's happening right there. The top one is shift up 1. The bottom one is shift left 1. Okay. Any questions on that? So now, I'm not going to do this both ways. Let's pick one. Do you guys want to do g of f or f of g? Doesn't matter. F of g. So we're going to find f of g of x. And then we'll do the domain. Okay, what I'm going to do, I'm just going to move this up so I got more space. So f of g of x. So we're going to plug g of x into f. So plug this in right here. We kind of did one like this earlier. So let's see what happens. Plug in square root of x for the variable. So square root of x squared minus 1. And what do I get from my, my final answer? Am I? Yeah, x minus 1. Now, the domain. Start with the inside function. What was my inside function in this one? Zach? G of x. Go back up to g of x and ask yourself, are there any restrictions on the original function g of x? Yeah.
You can't take a square root of the negative.
Okay, so in order to avoid what you just said, what values of x would I be allowed to use? Yeah.
0 or greater.
0 or greater. So the domain is already greater than or equal to 0. So we're starting with that. Now look at the final answer. Are there any additional restrictions on this formula right here, x minus 1?
You have 1,
You can't do 1 minus 1?
and then that'll get you 0.
Is that okay? Why?
Because you can't have the square root. Or,
Well, no square roots in here. You can take the square root of 0.
oh,
That's fine.
I thought
But just focus on what's circled.
no restriction.
There's no restriction here. You can take any number you want and subtract 1. So the only restriction in this domain comes from the original inside function. The original inside function was a square root. So it had to be greater than or equal to 0. Somebody looking at the final answer wouldn't know that, because they wouldn't have known where this came from. But we know where it came from. Right? And if you type it in on your calculator, a graphing calculator, watch what happens. If you type it in as x minus 1, the calculator has no idea that it should only graph it from 0 to infinity. Because, why would it? It doesn't know that there was a square root there. But watch what happens if you type it like this. The square root of x squared minus 1. So you might think that's the same thing, but now the calculator knows that there's a square root originally, and it'll cancel it out, and when it graphs it, it only graphs it from 0 to infinity. That's exactly what our graph should look like. Okay. Any questions on? There's a picture of it if you want that. All right, we're going to do another domain, but I'm going to combine it with a range problem at the same time. So remember, domain is what you plug in. Range is the answer you get out from the formula. So in order to figure out the range, the first thing we're going to do is find the domain. And then once you have the domain, ask yourself, okay, if I plug in the numbers in my domain, what will I get for an answer? That's my range. Now, the easiest way to figure that out is usually to use your calculator, right? And look at how high and low the graph goes. Okay, so domain you should be able to figure out without a calculator. Range, calculator is going to help us a little bit. Especially when we're graphing things that we don't know what they're going to look like. All right, in this one, again, we'll just do this one way. Let's do the first one. G of f of x. So G of f of x. Anyone think they can tell me what g of f of x will come out to? You don't have to give me domain and range, just the final answer for g of f of x. Chris?
X squared.
So there's no function here that's going to square anything. You've got some square roots and you've got a -3. But there's no way we're going to be able to end up with anything squared here. Yeah?
The square root of x minus 3.
Yep. If you basically take this and plug it in right there, you get the square root of x minus 3. Okay, so domain. Start with the inside function. Was there any restriction on f of x? Zach?
Cannot be less than 0.
Yep, so it has to be greater than or equal to 0. Okay. Is there any restriction on my final answer right there? Yeah? You could plug in a value for x that's more than 3. You could plug in 4, and that's okay. Like the square root of 4. You can do that. So we're just looking if there's anything here you can't use for x. Yeah?
There's no restrictions.
So negative 10 is okay?
For g of x. Or,
So we're looking at the original and then the composed function. Yeah?
It would be greater than or equal to 3.
How about 2? Could I take the square root of 2?
Yeah, you can.
I can. So 2 is okay there. Yeah?
Greater than or equal to 0.
It's exactly the same restriction that you got from the inside function. The inside function had to be greater than or equal to 0. The composed function has to be greater than or equal to 0. So the domain is just greater than or equal to 0. You didn't get any new restriction here. So greater than or equal to 0. All right, now let's do the range. Square root of x minus 3. Hit graph. So looking up and down, what's the lowest that it looks like that function ever goes? Yep.
2. 3.
So 2 would be like up here.
Negative 3.
Negative 3. Okay, so yes, it goes as low as negative 3. Actually, when x is 0, that's its lowest. And how high is that blue curve going to go? Yeah. Infinite. It's never going to stop going up. Square root functions never level off. They just go up slower and slower and slower. All right. So range. You all set, Zach?
Yeah, I'm good.
Okay. So range, let's see, negative 3 up forever. And that's it. Okay. Any question on that? Yeah.
So when you're looking for the domain, are you looking at the entire function? The square root of x minus 3, or are you just looking at the square root of x?
So when I look for the domain, first I start with the inside function. And I look at this. And I say, okay, any values I can't use there. And then I look at the whole final answer. Now, I look at the whole thing, and then in my head I say, what's not important there? Minus 3 is not important. When you're looking for domain, all I have to really focus on are square roots and dividing by 0. So the only part of this final answer that's actually important in terms of domain is this part right here. If that was a minus 4, it wouldn't have changed my thoughts on the domain there at all. If it was a minus 5, it wouldn't have changed my thoughts on the domain. Okay? Would have changed the range, but it wouldn't have changed the domain. All right, so yesterday we did a reflection in the x-axis. What do you have to have in an equation to make it reflect? What has to be there? Something, yep,
x squared.
Well, that's an example of something. So let's say you wanted to reflect that over the x-axis. What would I type in right now? Yeah?
Negative x squared.
Yeah. If we type in negative x squared, there's your original. There's your reflection over, oops, I meant to, sorry. I meant to put in negative x. Let me type it like this. Let's do negative x squared. Okay, so you got your original, and there's your reflection over the x-axis. Now, this one's not a real good one to tell, but let's try this. Instead of putting, let me type this in again. Instead of putting a negative in front, so here's your original. Here's what happens when you throw a negative in front. This is what we did yesterday. So that's just going to be the original, and then a mirror image over the x. Let's look at what happens if we throw the negative inside. So in other words, plug negative x into the function. So you have this. Anyone have a guess what's going to happen when I type this in? Negative x plus 3 squared. Yep.
It's gonna go on the x-axis.
It's going to reflect over, well, reflected over the x-axis yesterday.
Or y-axis.
The y-axis. Watch it. Watch the one in blue. Boom, mirror image over the y-axis. Right? So where you put the negative controls which axis it will reflect over. Okay? So from that example, you can tell that if you put the negative on the inside, it reflects over the y-axis. If you put the negative out in front, like this, that would reflect over the x-axis. So I'm going to summarize that in a chart along with the transformations we did yesterday. So if you missed yesterday, this chart I'm about to put up will be kind of helpful. All right, so we've examined transformations, this was yesterday, on quadratics. But every transformation that I taught you is exactly the same for every other kind of function. So if you know what that's going to do to the quadratic, then you know what it's going to do to this too. And you know what it's going to do to this. That's a vertical shift up 3, no matter which one you do. They're all shifting up 3. Okay, so transformations work the same on every type of function we're going to study. So I'm going to write down, I'm going to make a table. I need to use the letters A, H, and K. And these letters can represent positive real numbers. So positive fractions or decimals. And integers. All right, so let's start with this one. What happened yesterday when you stick a number in front of a function? Like x squared, 2x squared. What would the 2 cause the graph to do? Yep.
Stretch.
Yep, which way?
Vertically.
Vertically. So that's a vertical stretch. It could be a shrink if you put in a 1/2. Okay, so we went over that rule yesterday, but the idea is if you multiply a function by a number, it causes it to vertically stretch or shrink. Now, what happens if you add or subtract a number on the end of a function? We'll start with add specifically. So if you have like x squared and then x squared plus 5 on the end, what would the plus 5 do? Here?
It would move the graph up and down.
Okay, which way is up?
Positive.
and down?
Negative.
Negative. So this will shift your graph up if positive, down if negative. Sam, what if you add inside the function? What does that cause the graph to do?
Go left.
Let's think. Plus is going to go the opposite way. So yes, that's going to shift it left. What if you subtract inside the function? What does that cause your graph to do? Chris?
Can you repeat that?
What's that transformation going to cause? F of x minus h.
Horizontal shift right.
Yep, it's going to shift to the right. Now, if you put a negative in front of the function, that causes your graph to, that's what we did yesterday. What does the negative in front do? Zach? Flip it over
X.
the x. Now, if you put the negative inside, and what I mean by inside and outside is like if you had square roots, that's outside, that's inside. Okay. When you put it on the inside, that's what I just went over with you. Reflex it over the y. So now you've got a little chart of what happens when. Okay. Only thing not on that chart is a horizontal stretch. It's the only one I haven't mentioned yet. I'll mention it at some point. Okay, so let's see if we can use those rules to sketch a picture. Not even going to have a formula. All I'm going to do is give you a picture, and I'm going to ask you to transform it. So we're going to draw it. Here's your graph. And let's call that graph in black. I'll just do it off to the side. That's the graph of f of x. What I want you to do, I need to make it smaller so we can put it all on the board. What I want you to do is this. Sketch that. How many transformations are happening to take what I have to start and end up with the final answer? Yep. 3. And I'm going to do them in different colors. Okay. I could do it on a new graph, but it's easier for me to use the original. Let's do transformation in red. We'll do that one in green. And then we'll do the final answer in blue. Let's start with red. Adding inside the parentheses. What's the plus 1 going to do to my graph? Yep.
Left one.
It's going to shift everything left 1. So you're not writing a formula. Just move all your points left 1. Left 1, left 1, left 1. Good enough. Just enough to draw the picture. Okay, so that's the transformation in red. Now, what about the transformation in green? Multiplying by a number in front. Chris?
Shift to. Wait, no.
So when we multiply, when we add or subtract, those are shifts. When we multiply, it's always a, Emily? Stretch, which way?
Vertical.
Vertical. And which letters are your vertical? X's or Y's? Y's. So all your Y values are going to get doubled. Nothing's going to happen to your X's. So start with this dot right here. If you double that Y value, what happens to it? It's on 0, so it doesn't move anywhere. How about this Y value? Chris? Stays the same. The Y value is 0, and you're doubling, you're stretching it by a factor of 2. 0 times 2 is still 2. How about that Y value at the top?
Goes up to more units.
Goes up to 4. It was 2, and it goes to 4. So what you've just done is you took your image and you stretched it vertically. Now, what about the minus 3? You've subtracted on the end of the function. Emily? It's going to go down 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. So I know it's kind of hard to see, but in blue, that is the final answer from the image in black. Now, if you're wondering, well, how do you know what order to do these in? We went over that yesterday too. Okay, you've got an order in your notes. Okay, any question on that? All right, so yeah, that's good. So that's the homework for tonight on page 66. And that finishes up chapter 1. Okay, so we'll do a little bit of stuff in chapter 2 tomorrow. I'll be after school if you need extra help on anything. If you have a test you need to make up from the first week, tomorrow, Friday is it. That's the deadline.